All right, lesson 3-4.
Good morning.
Morning. So lesson 3-4 here. I got two problems on this bell ringer. It says expand this log and evaluate if possible. And I just want to remind you that last class we talked about there are three different types of properties. We had the product property, we had the quotient property, and I also had the power property. And I told you when you expand, you go through kind of like this order. Either way, whenever you expand, you must do the power last. Otherwise, you'll get the wrong answer. So this is the order that we'll do for properties. So when I look at this problem, something stands out to me really quickly. It's this division line. And so last class we learned that we have a property that if you have one logarithm that's dividing, you can separate it out into multiple logarithms where the numerators become positive logs and the denominator becomes a negative log. Is that ringing a bell with us from last class? That we could use the quotient property, and I could say that 2 log base 3 of 9xy squared over z cubed. I'm going to put my z with the line through it so it doesn't look like a 2. That is equivalent to 2 log base 3 of 9xy squared minus 2 log base 3 of z cubed. Now you see what I did there? This right here is called the quotient property. And I'm going to, for a time being, I'm just going to slide this down if I can. Sweet. So I have some more space. That's the quotient property. If you have one logarithm that's dividing, you can separate it into multiple logarithms where the denominator is a negative log and the numerator is a positive log. Are you okay so far with what I've done? Let's check this coefficient of 2. Did both logarithms get that same coefficient? Yes. Did they both get a 2? Yeah. Yes. They both get the 2, and they have a base of 3. Do both have a base of 3? So that portion doesn't change. All I'm changing is the inside of the logarithm. This part right here would be the inside number portion of the logarithm. Okay, so that's the quotient property. We also talked about what's called the product property, and that's this. You see how these logs are multiplying right here? 9 multiplies times x, which multiplies times y squared. We learned that you could separate those using the product property. And so we could actually say this is 2 log base 3 of 9 plus 2 log base 3 of x plus 2 log base 3 of y squared minus the same portion we had earlier, minus 2 log base 3 of z cubed. Now that right there is called the product property. And that's whenever you have a logarithm where the inside portion is multiplying, you could separate those factors into multiple logarithms that are adding up. So this one logarithm here with the factors 9 times x times y squared was separated into 3 separate logarithms, 9x y squared. Now to finish this off, I'm going to use my last property, which is the power property. Now the power property says if you have a power, it can be written as a coefficient that's multiplying in the front. So this 2 and this 3 are going to multiply in the very front. And while I'm on it, it also says to evaluate. So I'm going to evaluate this log. I can evaluate this front log because it does not have any variables any longer. Okay, gotcha, Pamela. So let's go evaluate what 2 log base 3 of 9 is. Again, I'm going to evaluate this. We're going to find out the answer is going to be 4. But I'm going to figure this out in the calculator. This one I'm evaluating because it doesn't have a variable. The other 3 logs have variables, so those won't be able to reduce. But I can reduce this front one by saying 2 log. Whoops, I forgot to do that. I got to choose the logarithm that's in the functions miscellaneous portion with the base right there. 2 log base 3 of 9. And like I said, the answer is 4 there. The reason being, it takes a power of 2 to get from 3 to 9. So it's 3 squared gives me 9. So this portion right there is 2. And then I multiplied it times this 2 and got 4. That's how I did that in my head. So I'm back over here. And what we found out is that front logarithm equals 4. This logarithm I cannot reduce. It's in complete form. This logarithm, the power of 2 comes up front and multiplies. It already had the 2. What's 2 times 2? 4. And then this 3 gets moved up front and multiplies. What's 2 times 3? 6. And there we got that by using the power property. So this original logarithm, 2 log base 3 of 9xy squared over z cubed, could be expanded to be this right here. This is the solution on this side. All of this is the solution. So the 2 log base 3 of 9 became the 4. Then I had 2 log base 3 of x, and it's positive logs because it was in the numerator. 2 log base 3 of y squared became 4 log base 3 of y. It's also positive because it's in the numerator. The denominator is negative. The 2 log base 3 of z cubed became negative 6 because 3 times 2 is 6, and it's negative because it's in the denominator. Negative 6 log base 3 of z. See how that worked out? So those are the properties from last class. Am I good to erase this problem? Okay, if not, I can pause, but I'll go ahead. I'm going to erase this. Actually, let me just see first if I can just slide down and just move the problem down this way. Brian and some friends go to the fair. Tickets cost the group $120. But Brian doesn't have to buy a ticket since he has his Dallas Independent School District ticket. They spend $225 on games, divided equally among him and his friends. If they all spent $40, how many friends went to the fair with Brian? Okay, so let's start basically, what is it we're looking for? What are we trying to solve for? Friends. So friends is our unknown. I'll call that X. Friends is our unknown. So now I see some prices. And as a reminder, the way you're going to solve this problem is basically you're going to do the old 6th grade math. If you have a total price and you divide that by the number of people, we get the average cost. I'm going to, because I'm running out of space, and say AVG, average cost. That's basically how we're going to set up this problem. And so I have 2 prices though, not just one, I have 2. So I'm going to have this fraction twice. So I have $120 that we spend. And I also have $225 that we spend. And all together, they all spent, this is the average cost, $40. That goes there. So all I need to figure out is how many people paid for the 120, how many people paid for the 225. So in this problem, tickets cost $120, but Brian doesn't have to buy a ticket. So who pays for tickets? Friends. Friends only. Who pays for the games? All the friends plus Brian, and Brian's the +1. So I'll put that over here so we know Brian is the +1. So this right there will solve our problem. And I'm just going to use a calculator for this. You can type in the whole equation. And if you do this, what will happen is it's going to put in a vertical line where the answer goes, or what the answer is, equals 40. So you see, this one actually has 2 vertical lines. There's 2 answers. But with real worlds, can we have negative answers or negative friends in this case? No, can't have a negative friend. And so this would be the answer right here, which we can tell the answer is 8 because this one's on a decimal. But in case this is, sometimes when we do these, I'll call this insolve here. If you're doing insolve and for whatever reason it's a problem, maybe it was like find the average amount of money or something was different where it could be a decimal and you can't see the decimal value, what you can always do is separate the equation into two portions where they're both y equals. You do y equals the left side and y equals the right side. I'm just going to copy this one. If you do, sorry, computer froze, y equals the left side, y equals the right side. And now what should happen is at the highest, the number that's by itself, that's where the intersection will be. If I zoomed out to 40 on the y, now the calculator, you can literally click it and it'll tell you your value. Whereas down here, it would not click, it's not clickable. This one up at 40, because that's the number that's by itself, you can click it and it tells you the exact answer is 8. So 8 friends went with Brian to the fair.